Yeah, all right. Thanks, Masha. It was a great talk. And thanks everyone for coming. Good morning to you in the Pacific, and all of you around the world. My name is Tal Melamed. I'm head of security research at Vertigo Labs. We're, um, we're an Israel-based startup, and we have a serverless security solution. And in this talk, I'm going to discuss the serverless security top 10 um, that we've created for and with OWASP. You probably all know. Just a few words about me. So my name is Tal, and you can follow me on either of these handles or links. I have about 15 years, just a little more than 15 years in the information security field, specializing in AppSec, from web, client-based, mobile, IoT devices, and now serverless. Uh, Probably, I can assume, well, I don't want to be presumptuous, but probably some of you at least don't know what serverless is. I didn't know what serverless is for about a year ago. Um, so it's a kind of a new technology that we're going to discuss now and see. So yeah, um, um, we at Protego, we provide a serverless security solution for companies have um, that have deployment and production serverless applications. And now, after I covered the housekeeping, let's start with a talk. So before we start, I'll just introduce you to serverless for a brief intro to technology because it's still new and many people still haven't heard about it or at least don't know about it. Um, so if we look back in the days where we had on-prem solutions where everything, including the data centers and the servers and everything was hosted on the premise, where the organization was based. And then throughout the years, we went through VMs and now recently containers, where there was a big hype through, and this is still, containers is still one of the most used technologies nowadays. Now, the move to serverless, if you look at this graph, the move to serverless really takes out from the companies, the organizations that build or develop the application, takes out most of the components that you need to deal with when you want to deploy or develop a serverless application. And that includes the operation systems and the setups and the patching and the monitoring, scalability. You don't have to deal with it anymore. So the idea of serverless is basically you have an idea, come up to the console or start with the IDE and start write your code. So the logic of the application, and you don't need anything else. You don't have to care about uh, purchasing or managing servers. You don't have to take care of your scalability. The service providers will take that care of that for you. So all you are left with is the application, which is the code, your code, and some configurations, which is also limited but had some security challenges. So, and we will discuss that. So, where are we on serverless, and is it here to stay? So we can see, so the first serverless, I think, was in this type of serverless term was first discussed about somewhere in 2014, I think, and then the first launch of AWS launching Lambda, which is the most famous serverless computing, the Lambda functions, was somewhere 2016. So we're only less than 3 years from that, and we're seeing a constant rise in the technology. I don't know if you were or heard about the last AWS reInvent, the biggest I think comes in technologies. They have like 60,000 people annually for their con, was mainly about serverless and also about security, which is good for us. So there is a big conversation about serverless, what it means and how it's good, also for security, but not enough. As you can see in this graph, there's just one search through this week, and I'm pretty sure that's me. So, but we can see that people start talking about the technology. So we wanted to make sure that the security is not left behind like every other technology coming in. So who are the serverless providers? Of course, the big players like GCP, Google Cloud Platform, AWS, and Azure are really dominating. Well, AWS is really actually dominating the market. I don't know about percentages, but they are way ahead of everyone. Some other players are joining in every time. I know SAP just announced their recently announced their serverless solution, and so you can see that the big players are providing these solutions. So this is something, or you can assume that this is something that they believe in, and they try to promote it that aggressively. So you can understand that it's going to stay. And not only that, if you think about who's there, one second, see, yeah, who are the first adopters for serverless? Who's using serverless? You can see very big players in the technology, and also not really high tech, but you can see Airbnb, Netflix is a big one, EA, AOL, Capital One, iRobot, Adobe. And this is not everyone. This is just the big ones or the first adopters. Then in the last reInvent, AWS showed who's using serverless. And you can see that many companies, many startups as well, are starting going serverless for many reasons. So I'll just uh, enumerate the few basics of why to go to serverless. Serverless infrastructure, the goal of it is that you don't need to deal with it. It's all managed. Everything is managed by the service provider. You come up, you write your code, and not only that, you don't pay for what you don't use. So you have an idea, you want to write a code. You don't have to deal with buying servers and managing operation systems and security patches. And not only that, if no one used your application or no one is using your code, then you won't pay for it, or at least you'll pay some insignificant amount. And when the applications start to scale up, they take care of the scalability for you. Of course, you will have to pay for it, but uh, you don't have to pay if it's not being used. And the architecture is maybe the reason for to discuss about security is that the purpose of serverless is or the type of architecture is a type of microservices. So everything everything in the application should be small microservices. Each function should do its own job, and you don't write a function that does the whole application process, but you write a piece of code that does its job, and that's it, and dies after. And it's important to mention that functions are stateless. So when they wake up, and I say wake up, but when they are being called or invoked, they are launched within a container that is provided by the provider. You don't have to deal with it, but it doesn't know what's behind it, what's before it or after it. It just runs the code and dies. And this is the ephemeral part. So after the code dies, you don't have access to anything that's left there. So you have to deal with it in various ways. So how do you take care of authentication? So there are many challenges there, and we'll discuss some of them. And the operations, of course, because you don't have to do that to scale. You don't have to make sure your operation system is up to date to patch for security. Your DevOps is really scaling down and is left for other things to do. All right. So let's do a quick gap analysis in security, and then I'll dive into the top 10. Um, we'll start with the cons. So of course, everything has a cons and pros. So you can look about the fact that you have no servers, and when I say no servers, I mean you as a company that develops the application, you don't have any servers. So why is it a con? Because you cannot deploy anything. You don't own the computer. You cannot be anything. You cannot monitor it your way. You cannot prove security controls. Where would you put your firewall, your IDS? You don't. because you don't own it. Another big con is that there is no perimeter. Um, in the traditional monolithic application, we are all used to one protocol, usually HTTP, but not always, coming in to your application. This is the entry point for the user, and this is where you put your all security arsenal to protect your application. But when you move to serverless, this is pretty much gone. You have this entry for through maybe API gateway, but you have functions are triggered through many through events. And events can occur from emails to MQTT notifications to entry in the database changing to files uploaded. Each of them can trigger a function, and you don't have this entry point to your application where you can put all your security controls. And of course, this brings to more complexity and high velocity of the application uh, of building multiple and many functions, small functions, rather than one big flow. Where you have, when you build a big flow, you can control it throughout the flow. But when you build microservices for access control, of the authentication on each of these functions separately. So this is also something that you have to manage. And of course, the rapid that this type of technology allows you to develop in makes it harder for the security teams to keep in pace. So if you have multiple functions deployed every week, it's harder for the security team to keep on track with that. But there are also pros. So yeah, I think the biggest challenge actually, the biggest pro actually is no servers. Think about it. You don't have to manage and to deal with anything, any server. Just write up your code. So take care of your application. So OPSEC is all you are left with for security, and everything else is managed and maintained by the provider. So fine grained, as I said. So if think about it like that, if each function does its own purpose, like let's say a function needs to write an entry to a database. That's it. So it should run for like 1 second or even 20 milliseconds, and that's it. So you can actually, if you could do it, maybe manually would be tough, but if you could give this function the permissions and the access control to do this action and only this action, this would really improve your attack surface or reduce your attack surface. Transparency, I look a bit at it like that. If you deal with containers, for example, you download a container, you deploying a container, you don't really know everything that's inside. You might know the things that you need to, but you also have to check which ports are open, um, what processes are installed there and running. Maybe you have a vulnerability there. So no, in serverless, this doesn't exist because you interact only with what you need, and you have only what you need. So if you're running a Python function, there is nothing inside but your Python code. Okay, there are some, of course, libraries, built-in libraries, but nothing is running there that shouldn't be running. Of course, if you find a 0-day in the provider's container, that's a big thing. And the ephemerality is the fact that everything dies after they stop running in a few minutes. Okay, I hope this is, of course, not enough to know about serverless, but it's all we can do so we can start diving into security. I suggest this is a very big technology coming up and probably would be part of the coming future. So I suggest that if you're interested in uh, keeping pace with the newest technologies, read about it. There are many security challenges and things to consider. One of the projects that we decided to open is the Serverless Top 10. Of course, if you're an apps guy, then OWASP Top 10 is the source for security risks and mitigations. So we thought that maybe a OWASP Serverless Top 10 would be a good idea to raise awareness. And we started that by taking the biggest security and serverless professionals and writing an interpretation of the original top 10. So people will start by understanding what is the difference when you shift to serverless because things aren't the same. Uh, so this is the current release. If you go to the project, you'll find a report stating the interpretation of top 10 into serverless. Eventually, the goal of the project is to have, of course, a serverless specific top 10. But we are currently running the project, and we're hoping to get some in the wild data from companies to get this done. Yeah, so there are some links here that you can get involved in. And let's start by diving into them one by one. And we'll see some demos and we'll see how they change when you move to serverless. So I call it SLS1, so it could, the name is random. If we take the injection part from the OWASP top 10, we call it in serverless, the known term is event injection. As I mentioned, functions are triggered through events. Events can be an API call, so you can send a REST API, but they can also be through, as I said, databases, cloud storages, etc. And there are, in this case, so there are many uncontrolled entry points to your functions, and you don't it's not enough to put not that it's not enough, but you several times you can't even deploy a firewall because don't have a server to deploy that. So where do you put your security controls? So there are still the traditional injection attacks, command injection, SQL, NoSQL, etc. They still live and exist because they are AppSec. They are different, so the entry point or the attack vector would be different to your application. And there are some new injections that you wouldn't consider when you develop a normal traditional application. So MQTT is now part, so IoT is a big part of our lives. So now you have MQTT coming in, you might end up with an injection. Same with emails. So you can send an email that will trigger a function internally even. So no one is really calling the function directly, but the fact that an email will send to a specific address might trigger a function. And if you take for example, the attachment file name or the subject and you parse it, you might end up with an injection. And so the impact in this case would be different for each function because usually, when I say usually, I'm talking about AWS, but each provider has its own type of security. So on AWS, for example, which is the biggest provider, you have a specific access control and permissions for each function. So what can each function do? And we'll get into that later into details. So the impact that if you have an injection in the code and your function is vulnerable to injection, someone somehow managed to exploit it. The impact depends on the permission that the function can do in the account. If the function can only write into the database, yeah, you might end up with someone modifying your database. But if the function has permissions to read the database as well, they can also read the database. Or if your function has other permissions like creating users, uploading or deleting or creating databases in cloud storage, and changing permissions. There are functions that change permissions. Deploying code. Wow, this is everything that we can actually find in the wild for customers. They use a template, for example, template permissions, because it's hard to do specific permission for each function manually. So when they do that, they end up with a bunch of functions that each of them is over permissive. And if they are somehow exploited, they can do very big harm to your account. You can end up with wasting all your money or even taking a complete takeover the account somehow. I don't know. So if they can create a user, they can change permission, then you can end up with it. So we discussed the no perimeter. So this is a before and after, some kind of to illustrate how it looks. So on the left side, before monolithic application, you had a load balancer or any other gateway into your function, into your code. This is the only way in. And in this case, you can see that the functions are triggered from processing data of analytic data, from uploading files from your gateway, from your databases, from the storage, and whatever you have on your application. When you start building serverless, you understand that this is a great thing. You can trigger code based on everything. This is great opportunity for developers, for companies, but it also raises about a few security issues that needs to be taken care of. So here is an example scenario. User sends in a mail with a CV attached or whatever, and the email reaches the server. Server doesn't belong to you; it's of the provider. And then you trigger an SNS notifications that triggers the Lambda to read the file from the database. So whenever files arrive into the server or into the cloud storage, you trigger a function that will indirectly go to the database, pull the file, and process it. And if the file name has some code injection and your function is vulnerable, you will end up with a code injection. And we'll see some examples. Let's see one now. Let's see how code injection in serverless app. So I'll introduce to you DVSA. We'll discuss it later a little bit more. It's a damn vulnerable serverless application that we developed at Protego and donated to OWASP because this is where I think we think it can grow best. And you can purchase items here. So for example, you add item to the cart. This is the usual process. And this is all 100% serverless, and you can submit. And let's say, for example, that I sent a function with, when I want to buy, I add an invalid credit card number. Okay, so of course the purchase will not succeed. And okay, so it didn't go through. Now if I go to orders, you'll see the order with payment failed. Okay, this is the order ID and the payment failed. So now I'll just tell you the function that uses this or gets this information is vulnerable. It seizes a vulnerable dependencies and it's vulnerable to injection. So I have this function that usually, if I look at the code, let's see, sorry, if I look at the events on the on burp to see, I'll see a pull request. 1 second. Let's do it again. Yeah, let's try again. So you can see on burp. Let's see that it's running. Yeah. Okay, I think that's enough. So you can see the request here, and the action is update an order ID with the items, and another request is coming in with before, yeah. So yeah, update because it's an order that was already launched. So now this is the original request. Now if I send it to a repeater so I can manage it, you can see that I know for that the function is vulnerable to code injection throughout different ways to do. There are different ways that I can just try out some payloads. So this what you can see here is this is the is an exploit. Now let me take you through the exploit so you understand how it looks. But forget this, for example, is just the header. So the function that handle this on the server side, the backend, I won't call it server side because it's not a server that we own, but on the backend is taking the original request, so the action, and then trigger invokes another function based on the input of the function, of the action. So if the function receives an action update, it will trigger an update function uh, on the backend. So what we do here, what it means that the function has permissions to trigger functions, other functions inside the application. And of course, you'll have to enumerate the system and see what's inside. But if you know that the function has permissions to trigger functions and the function somehow is vulnerable, then you can trigger any function that you want, unless, of course, it's restricted by the permissions. And in this case, the permissions were set to any function because this is some kind of what the function does. It's just invokes function. So if you look here, you'll have to, in order to exploit serverless application, you have to get familiar with AWS, for example, if these are AWS functions, that you'll have to get familiar with AWS code and through the AWS SDK, for example, of how to interact with functions or resources like databases. So what you can see here is that I have a code injection where I do require AWS SDK, and then I create um, a new Lambda. Lambda is the name of handling functions. And then what I do is I'm doing an invocation of a function where the function name is the DVSA admin update orders, and the invocation type is a request response, and the payload, which is P, which is coming right before. And then you can see that when I'll do that, um, yeah, I'll just replace the order ID here with the order ID that, sorry, with the order ID that was here. One second, let me go back to the clear orders. So here you can see it's payment failed, and I took the order ID and let's sec. Yeah, yeah, and I should the items that I want to run, and now when I refresh that, it is paid now, right? How was that possible? Because the function that uh, has code injection has the permissions to invoke other functions. So this is what I use. This is just one way of doing an injection attack on serverless. If you know that the function, for example, has permission to write into the database, you can just write a code that writes into a database. You do new client, say DynamoDB, and then you do DynamoDB put item, and you write an item into the database. So the attacks are the same, but the attack vectors and maybe the payloads, of course, are different. And of course, this is just one. As I said, there are many ways of injection attacks. I'll show you another injection part of injection attack soon. The second thing that we'll discuss is the broken authentication. For this top 10, again, is taken from the original OWASP top 10. We still don't have a top 10 design for serverless, but this is coming. So we said that the functions are stateless. That means that you cannot uh, you cannot put authentication into a session or something like this. You don't have that anymore. So how do you deal with that? There are many ways to deal with that, but the providers, of course, giving you some tools to do that. So for AWS, you have AWS Cognito, which handles your authentication uh, from outside the application. Um, it's maybe it would be less intuitive, but it works. But you have to deal with that. So for every function that runs up, you have to know how to deal with the authentication. Um, so again, you have multiple entry points. So it's not enough to put the authentication on your function interacting with functions with the users, but maybe somehow you have an injection or something, some other vulnerability in your application, and somehow someone can trigger an internal application. For example, this admin function is a back office. It's not even open through the API gateway. There is no way to call this function directly, but another function has the permissions to invoke functions, or maybe they are invoked through a normal service like an email or a notification. And if you don't put the authentication there, you might end up with with a broken authentication. This is a sample flow. So you have a function that you do a pull request. For example, you can interact with your code also. So you do a commit. It sends an email to the manager, which has to code review and then reply, and then it triggers another function that approves or declines the pull request or even deploy the code. But if the email itself, for example, the email address that you set up internally, let's say code deploy at myorg.com, then if someone can send an email to that email address, then they can trigger a function. Same with other scenarios like cloud storage, three buckets, etc. Next thing is the sensitive data exposure. So basically, it's the same in the cloud. So data are sensitive in the cloud and outside of it. The maybe the most common scenarios for you to understand in serverless is that when you launch a function, it runs in a read-only space apart from the slash temp library. So everything you want to write, you write into that slash temp, and if you don't delete it after you finish with it, someone could end up there stealing your data. Um, how do you put some configurations into the function? So you use environment variables. If you put up key unencrypted, you put keys unencrypted, someone can steal them. We'll see how we can steal the sensitive environment variables in just a few minutes. Uh, if you have buckets, cloud storage like S3 buckets or blobs, Azure blobs, and you put sensitive data there, then the buckets are configured or insecurely, people can just browse them. It's like the file folder browsing that we used to see on the monolithic application. Then someone can just see the files that you have there. And if you have sensitive files, they might end up in the wrong hands. There are tools like Shodan that shows you like open IoT cameras, etc. That there are tools also that can show you open buckets, and you can just browse there and see sensitive data, which is a big security issue. Okay, so another sensitive information that you might want to pay attention to is the function keys. So each function runs with environment variables that holds its keys. These keys are the keys that are used in the account to do what the function is allowed to do. So if the function is allowed to write deal with a database, these keys will allow you to do the same thing. This is what gives the function the ability to do that. So you can see here there are AWS access key ID and the session token and the security token. These are used to do the actions. Every other environment variable that you want to put here, I don't know, your keys to your Git or your keys to your Twitter account, they will show up here. So you better encrypt them. And we'll see next an attack on how you can steal these. Yeah, if you steal keys, you can do what a function can do, and you can run them from your computer at home. You don't have to be on-prem or something. They are in the cloud, and these keys can interact with cloud's resource. You can do it from your computer. You just need to download the AWS SDK so you can run, as you can see here, AWS DynamoDB list tables with the stolen keys, and you'll get the list of tables. And you can do everything that these keys allow you to do. Okay, we're short on time, so I'll keep the things faster. So XXE, external entity, they are still there. I would say they would be less common because you usually deal less with XML, but if you do, you can still be under VPC, or you probably would use a built-in libraries, which might, if you're using a secure version, um, might not have access XXE, but it doesn't mean they are not there. As you can see here, they are there, and you can do that. Um, Again, it depends on the configuration of the function. There is nothing new here rather than the function running in the cloud, so you might not end up, you might end up under a VPC, so you won't be able to go outside and steal this data, but it still exists. Okay, broken access control. Um, I call broken access control in a serverless overprivileged functions and resources. That means that function has a too permissive role. If the function needs only to write into the database, but can do everything in the database, and not only that, it can also do other things because the companies don't have the capacity or the knowledge to write a very specific permission, then the function can do things that they shouldn't be doing. And you need to understand how the permissions in the cloud provider works. So for example, I'll take this code. It doesn't do anything important. So this a function runs this code. All it does, it's reading a file from temp and creating a stream out of it. So it doesn't really matter what it does. So when you go and you say the developer to the developer that writes this function, okay, you have to assign a permission to the function because you're the developer, and they will come up with something like this. This is how a policy for permission AWS looks like. And they say, okay, I want to allow any action into an S3 bucket because the function reads a file from an S3 bucket, downloads it, I think, to the temp, and then reads it. Um, so I want to perform any action on S3 and on any S3 resource. So if you go to the AWS examples online, you might actually find that. But this is not security. So how would you do security? You would put uh, my bucket as a specific bucket that the function can do, and not only that, you would put the actual specific action that the function should do. So in this case, not only the function can only do get object, nothing else from the bucket, they can only do it from a specific bucket. So if you do that for every function, you can end up with a really, really secure architecture. Okay. Yeah, let's go through them. So 6 is a security misconfiguration. Functions, as I said, they not only interact with the user, also with the environment. The complexity of having thousands of functions or hundreds of functions is difficult, and you have to determine how many parallel invocations can you run, and the timeout. And these can end up causing you a denial of service or a denial of wallet, depends on how you configure them. A big problem with configuration is the S3 bucket, so I'll show you a demo. Uh, Sorry, there is a bucket that receives, there is a open bucket in this DVSA application. So you can see here I have a network, so it's an HTTP tunnel. And when I'll run, I'll upload. The bucket is misconfigured, and people can just upload files to it. It's okay on certain times, but you have to deal with it. So I'll run this command. So it's just basically copy any file, even if it doesn't exist, to this specific bucket. It will have a code injection here that says curl into my Angork here with an ls, right? So you can see that I got a request here. When I browse here, I'll see that the ls show backend. So oh, sorry. So since we have a short time, I'll skip the ongoing ls, how I examine the environment to see what's inside. And let's say that I do now cd backend, and then again ls, and then I'll know what's the next folder and the next folder and the next folder. And eventually what I'll do is this. So in this case, what I'm doing is this, yeah, cd backend, cd store, cd function. I cannot put slashes in the file name, so I have to do a cd each time, and then the file name is sender receive email. And what I do here is I do a cat of the code, wrap it into base4, and then sending it to my computer. So when I'll shoot that up, so no code, I just upload a file, and I got a request here, and now when I look at the next one, I can see a base64, which actually is a count of the file name of the file. So sorry, so I'll do this. Let's take this. Base64 decode. I'll get the code of the function running in your backend. So the same thing I can do is the env parameter, which gives me the permissions, the environment variable, which has the key. So if I'll do the same thing here, let me just shoot it up again. So it's not that, it's here. So instead of cut this, I'll do just env. Another request came in. Now I have, let's do it real quick. Base 64 minus decode, and you see that now I have the security token, the access key, and the session token, and now I can send requests to the function or interact with serverless resources using these credentials. And I might end up with many more things that in the account, or I can interact with databases and storages and etc. and users. All right, let's keep up. Cross-site scripting. So we have cross-site scripting. It's just that now it's a little different because it's not usually it's not a request going into the function and coming to the backend and coming back in, but it can also be through other resources. So if you can see here, I have a function that doesn't interact with an API gateway or something. So you don't really call the function, the code, but event, an SNS or a notification is sent when something happened. Let's say an email was sent, and I take the subject of this email, and then I put it into the function, and then I want to show it somewhere in the application. I might end up with a cross-site scripting that was sent through an email. This is not something that we used to before serverless. Many other scenarios, but we don't have time to cover them all. So okay, insecure deserialization. Again, it's there. It's not new. So the serverless allows you, or usually is very common for either Python or Node. Also Java.NET, and now AWS announced that you can bring your own language in, where you can run your own language. So these vulnerabilities will usually occur through third-party libraries, and you can still this is something that we find in the wild, so we actually found it on GitHub. A code that is running, it's serverless code that interacts with Telegram app. Okay, so and it's vulnerable to XFC, so to deserialization. So if I'll take this payload code here that does the same thing that we saw before, right? So runtime.get runtime.exec, and then env equals env base64 rep and curl into my computer, then I'll send this, and I will get just the environment variables, including the keys of the code. So again, it's the same attack, but you would attack it different. You have to know what you need, what are the resources that you, or the information that you can extract out of your application. Okay, moving on. Okay, vulnerable dependencies. It's number 9 on monolithic apps. I'd say it would be at least number 5. We'll have to see on serverless apps, because the fact that functions really do 10 lines of code. This is usually how we see it. So about no, sorry, 10, 100 lines of code can get to 300, even 1,000, but usually even less. So we'd say 100, 200 is the average. So how do you do so much, or how you can do everything that you want to do in these 100 lines of code? Because the function comes built in with a bunch of dependencies. Like, I mean, you need the SDKs, you need the parsers, you need something for your JWT authentication, and you need everything so that the function, the 100 lines of code that you wrote can do their job. And usually this ends up with vulnerable dependencies. And if we have a vulnerable dependency, even in one of the functions, and it's somehow vulnerable in your code, then you might end up with other exploits in your application. So this is something that is very important to monitor on serverless. And number 10, so yeah, time. Number 10 would be, of the top 10, would be insufficient logging and monitoring. So the difference here is, again, that you don't own the infrastructure, so you cannot put a logger or a firewall or an IDS that will monitor your network or whatever. It's not yours. You cannot deploy anything, but it's not there. You are left alone in the desert. The provider is giving you the tools, but you need to know first, you need to know how to interact with them. So you actually have to call them and to process the information that you get. But not only you need to do that, but you need to know how you can get the information that you want to get out of it. Because if you have a 1 million location of a specific function, how can you learn something from it? You have so much data through your logging mechanism that you need to actually write your own logs and monitoring logs and monitoring data, so you can actually get value from it. There are, of course, tools for serverless that use that. We, for example, as a company, we provide solutions for everything that you saw here. But there are companies that are not only for security, for that. They want to show you your debugging of your application. They exist. So you have to know how to use it and what to use. Okay, so we're about to be done with that. So how do you learn more? Because I'll tell you the truth, I'm still learning about it. It's a new technology. We're still learning every day. The security, serverless security community is active, and we're trying to learn more. Even I'll even tell you that the providers, so AWS, Google, Microsoft, they're still learning as well, because they dealt with the security outside your OPSEC, but you still own the code. So everyone is still learning. I have a blog that I cover a deep dive into each of the serverless attacks, as we saw here, with demos for each and every one of them. You can take a look. I'll publish the next ones, and I'm just going one by one there. Another thing is that the DVSA is open. You have 2 options, so you can use the online version. So it's a serverless.fail. You have an online version of the DVSA where you can interact with it, try to hack it, try to do whatever you want, really, and learn from it. And you can have, and we also have a published version of the code, so you can install it in your own environment, and so you can actually also modify and reconfigure it and do whatever. We'll have it in the marketplaces of the serverless markets soon, probably next week. So you can just click deploy, and you'll have it in your account without anything else. Otherwise, follow the instruction on the GitHub project. And we have an active Twitter account. If you want to shoot out to the DVSA or just to follow it, or I'll tell you a small hint. You actually, the DVSA is vulnerable and has some Twitter keys somewhere in the application. So if you steal them, you can actually tweet for as a DVSA itself. We'll release a DVSA exploiter because it's still very unknown, so people don't really understand it yet. So I'm going to release a tool soon that you can even put a proxy behind it and see everything that it does, which what it does is exploits different various of attacks into the DVSA, so you can see how you can so you can see how you can get orders from the database, how you can do impersonate to functions, steal keys, leak users, X vulnerable payment, etc., etc. And it will be through this exploiter, so you can learn about the DVSA. That's it. So thank you very much for joining, especially you in the Pacific where it's early in the morning. This was the only time I could do it because I have a flight to catch. Let me check if we have questions on the Takes a Crowd. And then I think, all right, no questions. So thank you everyone for joining. Yeah, keep following on serverless. I think it's going to be one of the next technologies that you should watch. Thank you.
Awesome. Thank you so much, Tal. Appreciate it.